Let's look at some more things with logarithms, including domain and what the values of these functions mean. So to start out, we're going to work with this function, f of x equals log base 3 of 2x plus 5 minus 23. The first thing we're asked to do is find the domain. And remember with logarithms, to find the domain, we take the argument and set it greater than 0. The argument is what we're taking the log of, so that would be the 2x plus 5. Set that greater than 0. And solve that by, of course, subtracting 5 from both sides. So 2x is greater than negative 5. Divide both sides by 2. So x would be greater than negative 5 halves. So here, if we're looking at interval notation, our domain would be from negative 5 halves to infinity. If we're in set builder notation, then we would have the set of all values of x such that x is greater than negative 5 halves. Set builder notation is pretty easy. You just have to chuck the inequality into that set builder spot. Okay, finding f of 1091. And then what ordered pair would that be on the graph? So that's essentially telling us that x equals 1091. So we already know the x part, 1091. And then we just have to figure out the y part. So we're going to use an input of 1091. So f of 1091 would equal log base 3 of 2 times 1091 plus 5 and then minus 23. So we get to work through this logarithm a bit. I'm just going to follow the regular order of operations for now. We'll do 2 times 1091, which is 2182. We add 5 to that, and we get 2187. So that is log base 3 of 2187, and then minus 23. Now this log base 3 of 2187, that is like in the order of operations, that would fall in the same level as exponents. So we've done what's in parentheses. Now we're in the exponent area. So we want to answer the question that this log is asking, which is 3 to what power gives us 2187. So we can start kind of guessing. 3 to the 15th power. Oh, that's way too big. 3 to the 5th power. That's too small. How about 3 to the 6th? 3 to the 7th. There we go, 3 to the 7th. So when it asks me log base 3 of 2187, then I'm just going to replace that with a 7 because that answers the question. So we have 7 minus 23, which gives us negative 16. So f of 1091 is negative 16, which would be, so that's negative 16. The ordered pair would be 1091, comma, negative 16. That would be the ordered pair on the graph. Now they're asking us kind of the reverse question. Find x if f of x equals negative 21. So now my output side is negative 21, and I'm looking to figure out the value of x, or my input. So I'll start by rewriting, and then I'm going to try and solve for x. I want to add that 23 over to the left side, so that gives me 2 equals log base 3 of 2x plus 5. Okay, I need to get this x out of the log relationship. So I'm going to break that relationship by converting it to exponential form. So I can break up the base 3 and the 2x plus 5. So then the base 3 is going to get into an exponential relationship with the 2, so 3 squared, and that's going to equal the argument of my logarithm, 2x plus 5. So then I have 9 equals 2x plus 5. In other words, 2x equals 4, or x equals 2. So x equals 2 when f of x equals negative 21. Oops, I went off the screen. Sorry about that. So the ordered pair that would be on the graph would be 2 for x and negative 21 for y. Now it's asking us to find a 0. Well, a 0 on a graph, another word for a 0 is a root or an x-intercept. So a 0 or a root or an x-intercept has the format some number, comma, 0. So what I can do is replace the f of x side, or the y value, with a 0, and then solve for x. So my first step, again, would be to add that 23 to the other side. So 23 equals log base 3 of 2x plus 5. I need to convert this to exponential form so that I can get the x out of the log relationship. So then that's going to give me 3 raised to the 23rd power equals 2x plus 5. Subtract that 5 from both sides. So 2x equals, goodness gracious, 3 to the 23rd power minus 5. And then when I divide both sides by 2, I'm really just going to leave it looking all crazy like this. 3 to the 23rd minus 5, all divided by 2, is my x value. And I'm seriously going to leave it in that form. So my ordered pair for the 0 is going to be the x value of 3 to the 23rd minus 5 divided by 2, comma, 0. Okay, on to solving equations. Well, we've already seen kind of some sneak previews of the strategies that we're going to use to solve equations. And that basic strategy is going to be to convert for convert a logarithm to exponential form to get the variable out of that log relationship, or to convert an exponential into a log to get the variable out of the exponent relationship. But there are some guidelines that we need to follow along the way, some little tips and tricks that I'm going to let you in on. So this one we are going to convert to exponential form. So here we go, doing that. We keep the base of 3, raise it to the power of 2, and then it equals the argument. So then we get 9 equals 3x minus 2, or 3x equals 11, which leaves me with x equals 11 thirds. Now we do have to worry a little bit about domain. So let's write ourselves a note when we have equations with logarithms. When you have an equation with a logarithm, you need to double check the domain to make sure that your solution falls within the domain. So, equations with logarithms. Find domain before you solve. Now, why do I tell you to find the domain before you solve? So that you don't forget, like I did. So we're going to look at our original equation. We're going to find the domain. So to find the domain of our original equation, we set the argument 3x minus 2 greater than 0, which means 3x is greater than 2, which means x is greater than 2/3. So the domain would be 2/3 to infinity. I got that answer. I want to check to make sure that that answer is within the domain, which it is. So then the solution to that equation would be x equals 11 thirds. Okay, let's look at this guy. Log base x of 4 equals 2. So again, we're going to try converting this and see what happens. So convert. So I'm going to convert the log into an exponent, which means the base is going to stay the base. So I have x to the second power, and then that's going to equal 4. Well, gosh, on this one, I definitely could take the square root of both sides so that I get, so if I do square root of x squared equals square root of 4, x equals plus or minus 2. Don't forget the plus and minus. Like, seriously, don't forget it. Or I could subtract that 4 over and factor it by difference of squares so that I get x equals plus and minus 2. Either way, I'll get x equals positive and negative 2. But here's a thing that you probably didn't know, and that is that the base of a logarithm has some restrictions. The base of logs must be greater than 0 and also not equal to 1. So when we get those two answers, x equals plus or minus 2, we're going to have to ignore the x equals negative 2 because it's not a valid base for a logarithm. So the only solution we would have would be x equals 2. Okay, so that's another thing to watch when you have an equation with a logarithm. This guy here, we are going to be converting this from an exponential into a logarithm, but before we do, we are going to need to isolate the base to the power. So I can't have 8 times 10 to the 2x minus 3. So I'm going to have to start out by dividing both sides by 8, which will then leave my 10 to the 2x minus 7 equal to 3/8. Then I can convert. So now at this point I can convert to a logarithm. So that base stays the base. So it's going to be a common log, which we don't write the 10. So it will be common log of 3/8, and that's going to equal the exponent of 2x minus 7. We would have to add the 7 to both sides. So log of 3/8 plus 7 equals 2x. Now this log of 3/8, that's like an exponent. Logs and exponents are inverse operations, so I cannot combine that with the 7. So it just stays that log like is its own little guy, and then plus the 7. Then when I divide both sides by 2, I'll have x equals log of 3/8 plus 7, and then the whole thing over 2, which I know looks weird, but that's how it is. Then thinking about domain, we only have to check the domain if our equation had a logarithm, which it did not. So this will be the answer or the solution to that equation. Okay, just a few more equations to look at. So here we've got log base 3 of 243 equals 2x minus 7. So I know that our go-to strategy has been converting from logs to exponents or exponents to logs, but that's when the variable is like stuck in a relationship that needs to be ended. Like here, I need to get that x out of the relationship of being in an exponent with e. Here, I need to get the x out of the relationship with the log base 5. Here, the x is over here being all independent, so it's fine. I don't want to put it up into the exponent because that would make things complicated. So instead, I need a different approach to this. I remember that log base 3 of 243 is asking me the question, 3 to what power gives me 243? So I'll see if I can answer that question. Let's see, 3 to the 5th. Oh, I got it right off the bat. 3 to the 5th is 243. So I can replace log base 3 of 243 with the number 5. So now I have 5 equals 2x minus 7. And that's going to be a really simple equation to solve. Add that 7 over, that's 12 equals 2x, and then x equals 6. Now let's think about domain. Remember, we had to think about domain. Now we're responsible for 3 times. 1 if I have variables in the denominator, 1 if I have variables in even index radicals, and the other if I have variables in my logs. My variable is over here by itself, not in a log, so this equation has no domain concerns. So 6 is the answer, and the answer is 6. How about this next one? E to the 2x plus 5 equals 8. So in this one, the variable is in a relationship that needs simplified. So I'm going to switch it from exponent to log form. So I keep the base of 8. And remember that when we have a base of 8, when we have a base of e, that means we have a natural log. So we don't write log base e. Remember, we write natural log like that. So we'll have the natural log of 8 is going to equal 2x plus 5. Natural log of 8, I mean, that's like, writing a square root of 8 or something like that. Like, it stays itself. So when we subtract that 5 over, we're going to get natural log of 8 minus 5. That cannot be combined to be natural log of 3 or anything like that. Just stays natural log of 8 minus 5 equals 2x. Divide both sides by 2, and we'll get natural log of 8 minus 5 all over 2. And in no circumstance can anything here be divided by that 2. You cannot divide a number that's inside a log with a number that's outside a log. No way, no how. So this is what I would call an exact value. And that's what I'm looking for when you answer a question for me. But they may ask you for a decimal approximation. And in that case, you will need to move to your calculator and then answer to whatever level of accuracy they request of you. So for our decimal approximation, we're going to ask the calculator to do the natural log of 8. Natural log is next door to the 4. So the natural log of 8, close that parenthesis off, and then subtract 5, and then divide that result by 2. So what we get from the calculator is negative 1.4602799229, and then whatever they ask you to answer to. So if they ask you for 2 decimal places, like negative 1.46. All right, this guy, solve for x. So our variable this time is in a log relationship, and we need to simplify that. So we're going to need to get that variable out of the log, which means we're going to need to convert. So when we convert, we will have 5 squared equals x squared plus 4x plus 4. But before I get too far down that path, I do want to remember to look at my domain. Because I have a logarithm, I need to set the argument, x squared plus 4x plus 4, the argument to be greater than 0, so that I have a working domain when I get done to check my solution against. This is, unfortunately, another nonlinear inequality. And you know what that means. If we have a nonlinear inequality, that means we're going to need a test chart. So I replace my inequality with an equal sign. I'm going to solve that equation. This one factors nicely. I get x equals negative 2. Remember that that is going to be an open circle because my original inequality was a greater than. And I need to test a number to the left of negative 2, like, I don't know, maybe negative 5. And to the right of negative 2, like maybe 0. And see where we come out true and false. So x squared, which would be 25, minus 20 plus 4. So that is 5 plus 4, which is greater than 0. So that is true. And then over on 0, 0 plus 4 is greater than 0. 4 is greater than 0. That is also true. So how does that work? Well, that means that my domain is true here, and my domain is true here, which means that my domain goes from negative infinity to negative 2, but skips over negative 2 and goes to infinity. So my domain is actually all of the numbers as long as x doesn't equal negative 2. So the only number it's not allowed to be is negative 2. That should be pretty easy to avoid. So back to solving our equation. We have 5 squared equals x squared plus 4x plus 4. So that would be 25 equals x squared plus 4x plus 4, or 0 equals x squared plus 4x minus 21. That is going to factor into x plus 7 times x minus 3, which gives me x equals negative 7 or positive 3. Check that against my domain. The only restriction was that x could not equal negative 2. So this little guy has 2 solutions.